Hello students, welcome to the Yupp Master Foundation program. Today we are going to deal the very interesting topic regarding to the properties of light, which is very important for competitive examinations and also for higher studies. Let us see, if you are going to take that properties of light and related problems. Before that we will discuss the properties. Let us see. If you are going to take that light, yes, it is emitted from the source in the straight line path and it is going to be in the form of wave. Let us see, billions of photons are emitted and they are going to be in the form of wave. They are transmitted in the form of wave. Let us see, if you are going to take this is the wave nature of the light, this is the lambda wavelength. We would like to take about this wavelength, how it is changes from one medium to another medium. Whenever light is allowed to enter from one medium to another medium, there exists a change in wavelength and also change in the speed of light. It is very clear, we are going to know about this wave nature, so that light possesses the dual nature. All right, you can take that. Light possesses dual nature. Light has dual nature, that is wave nature and also particle nature. Very clear, that is what we are going to tell, that dual nature of the light, and it has been represented with their equation. According to quantum theory, we would like to know that energy has been expressed E is equal to h nu. We can take that n number of photons are emitted, we would like to write it as n into h nu. So, energy of one quanta has been represented as the h nu. It is very clear, h is the name of Planck's constant. Its value is going to be 6.625 into 10 to the power of minus 34 joule second. All right. Now, let us go for this one, how the light is going to be propagated, that is a rectilinear propagation of light. We are going to take that from the source. You can see that this is the source. From the source there are three apertures which are having the tiny hole, and the light is allowed to pass through this. It has been observed by a person, it has been travelled in the straight line path, no doubt at all. So, it is going to be in the straight line path. It is going to be in the straight line. Yes. So, that is the rectilinear propagation, no doubt at all. That is what, if you are going to take that, whenever it has been interfaced by any object, what happened? Let us see. If you are going to take that, so there exists a reflection of light and also refraction. You may identify that light is going to be reflected and refracted. So, it depends on the nature of the material which has been incidented and also angle of incidence. Okay. Let us see that. If you are going to take that, this is a one, light is incidented, right. This is a one smooth surface which has been taken. Light is incidented, this is the incidented light ray, please see that. I is the angle of incidence and R is the angle of reflection. So, the phenomenon of reflection is limited to one media, that is going to be in the same, it is going to be reflected back into the same medium. All right. If you are taking that is incidented ray, that is the angle of incidence, and with respect to the normal we will identify, we will measure that angle of incidence and angle of reflection. So, the perpendicular distance from the point of contact to the surface is known as normal, all right. Now, you are going to take that this is our angle of reflection, no doubt at all. Now, if you are going to take that, it is a reflected ray. So, angle of incidence is equal to the angle of reflection according to the Snell's law, it is very clear. That is what you are going to get this one, I is equal to R. I is the angle of incidence and angle R is the angle of reflection. It is true for that smooth surface only. If you are going to have that irregular contacts, that is irregular surface is there, na, there exists a diffused reflection. This is the regular reflection. It is very clear. That is what we are going to take that one important point regarding to this one. So, the incidented light ray and you can take that this is a one plane. If we are going to take this one, this is a one plane, let us assume, we would like to take this. So, the incidented light ray and the reflected light ray, they will lie in a one plane, this is a one plane, this is a one plane. All right, you are going to know about this one. The incidented light ray and the reflected light ray, they are going to be confined, they are limited to one plane only. That is very clear. Suppose if you have taken that refraction, it is going to be entered into another one, that is a case we will discuss. So, here we would like to take this one, this is a normal, and we are going to know about this I and R. So, I is equal to R, that is the one, and incidented light ray and reflected light ray, all are both are confined to one plane only. That is the case we are going to take that Snell's law, right. Suppose if you are going to take that refraction, while you are going to talk about that refraction, what happened, let us see. So, two different media are there, light is allowed to incident, what happened. So, it has been refracted, this is the refracted light ray, refracted light ray, all right. Now, if you are going to take that refracted light ray, there exists a change in its speed and change in its wavelength, but frequency that remains same. Okay, let us go for another one. What happened? It has been refracted through the boundary, through the interface, it is very clear. So, if you are going to talk about that, this is one case we are going to take that. Yes, another ray, it is a total, you can take this one. If you are going to keep this, this is the total internal reflected light ray. Very clear. You are having that three phenomena, refracted at 90 degrees, it has been refracted through the boundary, through the interface, very clear. So, in this case we are going to take that 90 degrees, or is the 90 degrees. Okay. If you are going to take this refracted ray, that is angle of incidence I, is going to be less than critical angle. In this case, we are going to take that, angle of incidence I is equal to critical angle. In this case, angle of incidence I is greater than critical angle. Very clear, we are going to have the 3 cases. So, when it has been refracted, we can apply the Snell's law, that is mu1 sin I is equal to mu2 sin R. Mu is the refractive index of the first medium and mu2 is the refractive index of second medium. Alright. Now, easily you can find out that angle of incidence and angle of refraction by knowing that, by knowing the speed of light in 2 media. If you know the speed of light, just you can estimate that refractive index. If you are going to take the refractive index, what is that meaning? If you are looking into that matter, the speed is reduced by the refractive index times in that medium. Suppose you have taken the light is entered into the glass medium. The speed of light is going to be 2 into 10 power 8 meter per second. That is very clear. If you are taking that, the speed is going to be reduced by the 1 by mu times into the refractive index. It is very clear. If you are going to talk about that refractive index, how many times that speed is decreased, reduced, it is very clear. So, we are going to take that V is the speed of light in that medium and mu is regarding to that. If you are going to take that glass material, if you can get this. So, for the glass material Ri is 1.5. If you are going to take that for glass, mu is equal to 1.5. So, V is equal to 1 by 1.5 into 3 into 10 to the power of 5. Easily you will get 10 to the power of 8 meter per second. You will get that, just you can get the cancellation, 10 to the power of 8 meter per second. It is very clear. If you are going to take that water, it is 1.5 into 10 power 8 meter per second. Yeah. Okay, all right. Now, if you are taking that, these are the different cases for the incidented light rays which are going to be refracted, through the boundary at 90 degrees, which are totally internal reflected. All right, we can solve the problems by using these relations. Let us go for these problems. Yeah, we can see that is that critical angle. You can define the critical angle also. That is the critical angle. It is the one reference. Critical angle is different for the different materials. All right. Now, you are going to take that, based on the critical angle we can solve the problems. That is, if you are getting this one critical angle, that is sin C is equal to 1 by mu. This is the relation between the critical angle and the refractive index of the material. Yes, let us go for this one. So, you can see that the speed of light in medium m1 and the speed of light in medium m2 are given. What we had, 2 into 10 power 8 meter per second, 1.5 into 10 power 8 meter per second. It is very clear. Okay, what happened? If you have taken that light has been entered from one medium to another medium, in order to get the total internal reflection, what is the angle of incidence? What is the value of I? You have to calculate this one. We are going to take that medium 1 and 2. At the same time, we have to look into that speed of light in first medium and second medium, very clear. That is what we would like to go for this one diagram. We would like to go for this one Yeah, this is M1, this is M2. Light is getting the total internal reflection. Please take that. Yes, this is the incidented light ray. In order to get the total internal reflection, that is I should be greater than critical angle. What is, see here, you will get this one, this light is going to be total internal reflection. It is going to be reflected. This is the total internal reflected light ray. Reflected light ray. Very clear. So, you wants to find out that critical angle, just you can apply that Snell's law. Very clear. What they are going to, yeah, we can use this space, right. Now, if you are going to know about that, see, it is the critical angle, right. Now, how you will find out that critical angle? Yeah, you are going to take this, this is the case, what is the speed? That is V2, that is V1. We would like to take that V2 and V1, or the speed of light in first and second media, right. You can apply that Snell's law. By Snell's law, what we can do that? Apply Snell's law. Law of refraction, that is, you can take that, yeah, mu 1 sin I is equal to mu 2 sin R. It is very clear. Suppose if you are going to know about this one, it is very clear. Yeah, if I is equal to C, then you are going to observe that this is the case, we can confirm this is 90 degrees. Yeah, angle of refraction is going to be 90 degrees. If I is equal to C, then R is equal to 90 degrees. All right, we are going to take this one. Then R is equal to 90 degrees. So, you can write this one, mu 1 sin C is equal to mu 2 sin 90 degrees, very clear. Therefore, sin C is equal to mu 2 by mu 1 into 1. So, sin C is equal to, what about mu 2? Just you have to know that mu is equal to C by V. That implies mu 1 is equal to C by V1, mu 2 is equal to C by V2. You can write down C by V1 whole upon C by V2, that is equal to V2 by V1. All right. So, what they have given, this is 1.5 into 10 power 8 is the V1, 2 into 10 to the power of 8 meter per second, that is the V2. Just you can apply and you will get this. If you know that C value, then only you will estimate that what is the angle of incidence that must be greater than critical angle, right. Now, you will write down sin C is equal to, what about that is, yeah, you will take that 2 into 10 power 8 meter per second whole upon 1.5 into right 10 to the power of 8 meter per second. all right. That is going to be 2, you can cancel this, 2 by 3 by 2, that is 4 by 3. Yeah, it is going to be, sorry, just you have to get this one. Yeah, we will take that sin C is equal to, right, just you can take that. This is the case equal or less than that of yes, we can take this one. Yeah, it is going to be, we are going to take that sin C, it is equal or greater than that of 3 by 4, we will get this one, right. It is very clear, if you are going to get this angle of incidence must be greater than that of critical angle. That is, you can easily find out that, yeah, you will take that, this is, yeah, this is for the first medium M1 and this is M2. You have been applied that Snell's law and you have been taken this one and you are going to get this one. Please take that. This is, you can solve this problem by applying this. Yeah. This relation plays very important role to solve the problem, all right. So, let us go for another problem. If you are going to look into that matter, just you can see yeah, what happened if you are going to identify that, if you are going to take that the apparent depth concept. So, the light is entered other than 90 degrees, light is entered other than 90 degrees, the object which is going to be appeared rise to some distance, it has been rise to some distance. So, you can easily identify this one. Yeah. See this, if you are identify this case, yeah, we are going to take that this is a one fish, it has been observed through a convex lens. Yeah. If you are going to take that concept of apparent depth, what the actual presence of the fish is going to be different, it is going to be raised when we are going to observe from the rarer medium. Just you can see that if you are going to identify, the image of the fish is going to be calculated. Suppose if you are going to observe through this angle, you have to calculate that what is the image distance, where the image has been formed, you can identify this, this is very clear, and they have given refractive index of that water also. So, a small fish that is at 0.4 meter below the water surface, and where the lens has been placed above the water surface, that is 0.2 meter. Yeah. The fish lies on the optical axis of the lens, this is the optical axis, this is the optical axis, very clear. Now, if you are taking that it is going to be identified with UV method and which is related to focal length. Please take that. What is our aim in this problem? We have to calculate that the image of fish seen by the observer at what distance. That is very clear. You have to identify this. From this convex lens we are going to observe that. So, this is the optical axis. Yeah, you have taken that 0.4 meter and 0.2 meter. Now, we would like to take that apparent, yeah, we are going to take this just you can see. Yes, you can take that the apparent distance of fish, that is equal to whatever that this 0.2 plus, and that let us assume height h be that, yeah, we will take that h by mu. Yes. So, what is that height? Here we are going to take that 0.4 meter actual presence. Now, we would like to get that calculation. Apparent distance is going to be u. Now, we are going to take that mu is equal to 4 by 3, all right. You are going to identify this, yeah. Now, you can write down 0.2 plus 0.4 by 4 by 3. You can take this calculation, that is 0.1, yeah, 0.2 plus 0.5 meter, let us assume. So, if you are identifying this apparent distance, then we will solve the problem. Yes, you are having that u is equal to 0.5 meter, very clear. The image distance is going to be v. You can take this image distance, yeah. Image distance is v. Now, we can apply that known formula, that is 1 by f is equal to 1 by v minus 1 by u. Yes. So, you have taken that u is going to be negative, right, because of the sign convention u is going to be taken as negative, right. We can solve this problem by applying this formula, right. It is very clear. You are going to rough some part, yeah, you can use. All right. Now, we would like to go for that UV method. You can substitute that, and they have given the focal length. What they have given, just you can see that. Yes, this is the focal length 3 meter, that is 1 by 3 is equal to 1 by v. You are going to be calculate that v image distance, where that image of the fish is going to be appeared, that is minus of 1 by minus 0.5, which is going to be meter, right. Now, 1 by 3 is equal to 1 by v, it is going to be minus of 1 divided by minus 1 by 2, that is equal to 1 by v plus 2. Simply 1 by 3 minus 2 is equal to 1 by v, right. Therefore, 1 by 1 minus 6 by 3 is equal to 1 by v. You can easily solve this one, that is Yes. So, finally, you will get that V is equal to minus 3 by 5, that is equal to minus 0.6 meter. So, that sign indicates in the same side, just you can confirm. A distance of 6 meter from the water surface, the distance of 6 meter from the water surface, it is very clear. So, this is the correct one, second one is the correct option, it is very clear. Now, you can go for this formula once again. Very simple, we have taken that apparent distance, at the same time the apparent distance is nothing but u, we are going to get that u. At the same time you wants to find out that v value, that is nothing but the image of the fish where that it has been located. Okay, you can apply that formula because they have given the focal length, it is very clear. After applying all these things, just you can get these calculations and final answer has been confirmed. This is the final answer, very clear, right. It has been viewed at 90 degrees, remember. So, just you can see that, right. You can take this one, this is very simple problem. When a rectangular tank has been filled with the liquid, we do not know that what type of liquid. Whenever it has been viewed from the surface, top surface, you have been identified that refracted light ray, it has been refracted and which is going to be refracted through the boundary at 90 degrees, it is very clear. So, you can easily identify it. Yes, this is going to be 90 degrees, it has been observed at 90 degrees, all right. Now, you are going to take this problem and they have given the dimensions also, 3 centimeters and 4 centimeter, and it was encrypted. Just you can see this is the u, mu is the refractive index of that liquid. What is your aim? Just see the problem. The refractive index of liquid is going to be calculated, all right. This is the liquid, you have to find out that refractive index mu is equal to question mark, that is the case. We know the concept, just we will apply. The light ray has been refracted, yes, and it has been identified through the surface, in the problem it is also mentioned. So, when the rectangular metal tank is filled to the top of with an unknown liquid, an observer with eyes level the top of the tank can just see the corner E, it is very clear, he has going to be identified that corner E. A ray refracts towards the observer, means it is going to be refracted at 90 degrees at the top surface, then the refractive index of the liquid. Do you know the concept? This is very simple concept, just you will take this one. Whenever you have taken that light, it has been identified. So, it is going to be theta c, it is then only it is going to see that 90 degrees. So, here in this problem it is going to be taken as I, it is going to be, yes, please see that, this is very clear, easily we will find out that. Do you know that from the figure you can get this, sin c is equal to, sin theta c is equal to 1 by mu, it is a known relation. If you are going to take that, sin theta c, if you are taking that sin theta c is equal to, this is going to be calculated 4 square plus 3 square, that is 5. All right, it is very clear, very clear. Right, this is identified 5, right, this is going to be identified 4 also. Now, you can take this now you will take that sin theta c is equal to 4 by 5. So, you will take that 4 by 5 is equal to 1 by mu. That implies mu is equal to 5 by 4, that is equal to 1 point, just you will take that 5, just you will, you can identify this. Let us see that if you are identifying this, you will calculate this one easily. Just after getting that identification, it is very simple to calculate that. So, this is the first one, this is the first one, the second one. If you are going to take this one, mu is equal to 5 by 4. So, this is first one and second one. But meanwhile, you are going to take this one sin theta, that is from figure, from the figure we are going to calculate this one. Now, you will take that 1.2 some value. All right, just if you are taking that, they have given that 1.25, just in the answer, just you can check it, that is 1.2, it is a correct answer. So, these kind of problems are going to be solved very easily, just you will apply the concept critical angle. When you have been incidented at critical angle, what happened, it is going to be refracted through the boundary at 90 degrees, it is very clear. So, the problem is going to be 4 or 5 lines, but the internal concept you have to identify, that is very, very important, right. So, easily you will find out this phenomenon, this one, this is the eye, it has been observed. All right. So, everyone has to identify the diagram based questions. What is the internal principle which has been involved in that matter? You have to solve this one. Say yes or no. So, finally, we have been achieved that concept, and it has observed 90 degrees, that is. So, how we are getting this relation? Simply you will take this, you can take that mu 1 sin, just you can see, mu 1 sin I is equal to mu 2 sin R. So, mu 1 sin C theta C is equal to 1, mu 2 is the 1 and 90 degrees. So, sin theta C is equal to 1 by mu 1. So, that is water. It is very clear, just we have applied the Snell's law, and in order to get that angle of refraction, it is going to be 90. All right, students, it is very important for the entrance examinations. Please follow the classes regularly and convey to all your well wishers. So, thank you very much. Have a nice day. Hello students, welcome to the Yupp Master Foundation program. Today we are going to deal the very interesting topic regarding to the properties of light, which is very important for competitive examinations and also for higher studies